This is a video on how you solve problems, usually mathematical problems, in Mr. McLeod's chemistry class. By this time, you should have opened up this page and read it, um, and also this page and read it, and this page, which is an example, and take a look at it. In solving problems in chemistry, mathematical problems, that is, there are two ways. One is called dimensional analysis, which basically is a way of doing math without actually using equations, and it's units that determine everything. And the other way is by equation. You've done this in math, but I'm going to make you do it in a certain way that may be counter to what math teaches you. A lot of times you could use either method, dimensional analysis or by equation, to solve a problem. And sometimes you have to use one or the other depending on the information given. So this one is going to be, this video is going to be about dimensional analysis. Dimensional analysis, or the other set of words people use, is the unit factor method. Again, the big thing here is we're going to keep track of units and make units cancel until we get the unit that we're looking for. Now, there are certain steps you're going to follow in solving a problem, no matter if you're using dimensional analysis or by equation. And the first two steps are always done, which is, and you can do them actually in either order. Write down what you're looking for, the unknown thing, and then write down what you know. When you write down what you know, sometimes you don't have to write down known conversion factors like 12 inches in a foot, but you need to write down the information in the problem and the big conversion factors that you're going to be using. So that's the first thing you do. So if you look at the example, again, those two things are done no matter if you're using dimensional analysis or by equation. So if you look at this, the question we are going to use for the first question, we're going to look at 2 for dimensional analysis. So you look at this when Ronald McLeod is driving a car going 26.4 kilometers per hour. If he rides 4.51 times 10 to the 9th centimeters, how long does it take him in seconds? So the first step is, what are you looking for? You're looking for seconds. And in this problem, I'm going to abbreviate seconds as SEC instead of just S, because sometimes people think my S's are 5s. Then the other thing I know is 4.51 times 10 to the 9th centimeters and 26.4 kilometers per hour. I do know a lot of conversion factors between centimeters and like centimeters and meters and kilometers and hours and minutes and all that, but I didn't write them down. Okay. So now the task is, I have my information, known information, and I have my unknown information. How do I get one to the other? So what we're going to use here is dimensional analysis. So once you have that information, to do the dimensional analysis, you have to put some information first. And the key is to figure out what information to put first. You go to, as it says here, in step 3, setting up the answer, look at the units in the answer to determine the first thing you write down. So in this question here, I am looking for a substance or a thing that has 1 unit. So I put down a 1 unit information that I know. And since we only really have 2 pieces of information, we're looking for we write down centimeters. I'm trying to go from centimeters to seconds. Well, centimeters is a distance term, seconds is a time term. So somewhere embedded in my problem, okay, my answer method, what I want to call it, I need a conversion factor between distance and time. Well, do I have it? Yes, I do. It's this speed. So therefore, and this is dimensional analysis, after you write down the first information that you get, in this case it's a 1 unit thing, what you do is you set up these brackets, and I think they're called parentheses, and a line. And you just keep on making more and more and more of them. And what they're used for is to change units. So I have centimeters. I don't want centimeters. What I want to get to is I want to get to a distance unit that I have a conversion between distance and time, which is kilometers per hour. So I have to change my centimeters eventually into kilometers. Now, have you memorized directly centimeters and kilometers? And if the answer is no, then you have to go to the unit, an intermediate unit that you have memorized. Well, you have memorized centimeters to meters. So that's the first thing I'm going to do. Now, if I want to get rid of centimeters, do I put the centimeters on the bottom or the top? Well, of course, as you know for math, if it's on the top, to get rid of it, you put it on the bottom. So that's why the centimeters is on the bottom. And we're looking for centimeters to meters, so the meters are on the top. So therefore, that's how I know we put the 1 meter on the top and 100 centimeters on the bottom. Because as you know, there's two relationships or two fractions from knowing that 100 centimeters is equal to 1 meter. It's either 1 meter over 100 centimeters or 100 centimeters over meters. And as you know, the 100 goes with the centimeters and the 1 goes with the meters. So it's not if you're dividing or multiplying the 100. It's where the units are located. And you need the centimeters on the bottom to cancel the centimeters in the original unit. So now I have meters. Okay? I don't want meters. I want kilometers. That's why meters on the bottom and kilometers on the top. So now all of this I have kilometers. So now I want to put the kilometers on the bottom and hours on the top. And if I multiply all this, I have hours. And that's why the 26, if you look, 26.4 kilometers over 1 hour. That's why the 26 is on the bottom. Now if I do all the math here, which you don't, in dimensional analysis you do everything to get to the units you want, and then you do the math. So I don't want hours. So how do I cancel hours? Well, I put it on the bottom. But I know a conversion factor between hours and minutes. That's this, 1 hour to 60 minutes. So hours cancel. And I don't want hours, I want minutes, I want seconds. So I know that in one minute is 60 seconds, and I put the minutes on the bottom because they're cancel, then I get seconds. At this point, I don't need to make any more brackets because that's the unit I'm looking for. So therefore, now I get my I'm going to get my answer. Okay. Now, how do you actually do this? As you can see, I didn't multiply the top, write down the number, multiply the bottoms, get another, then divide. I simply gave you a number, and that's what I'm expecting. How do you do that? Well, since all of dimensional analysis is multiplication and division, as long as I just do two things and hit the equal sign, I get my answer. So I take the 4.51 EE to the 9, divided by 100, hit the equal sign, divided by 1,000, hit the equal sign, divided by 26.4, hit the equal sign, times 60, hit the equal sign, times 60, hit the equal sign, and I get this number. And as you know, with significant figures, it's the last step. In dimensional analysis is always multiplication and division. So you go up to here and look, 3 sig figs, 3 sig figs. My answer needs 3 sig figs. Here I need 4. So when I look at the number, I need 4 significant figures. Since it's greater than 1,000, I need to put in scientific notation. So this is my answer in scientific notation with four significant figures in units This is with rounding to 3. That's my answer. Okay? And that's how you do it. So that's how it is. You can't make conversion factors unless, like actually calculate to get conversion factors. You either got to know them or you have to have memorized them. Okay? So that's an example. That's an example of dimensional analysis. Now here's another example. Here it says Ronald McDonald is driving down the road going 26.4 kilometers per hour. How fast is he going in centimeters per hour? So unlike the first one, which you'll see in a different video, I can actually do an equation called the speed equation to solve this. This one here you can't, because all we're doing is going from one unit set to another unit set. So you'd have to use dimensional analysis. So you use it the same exact way, as you know. You look at the question, you ask yourself, write down the unknown, write down the known information. I'm looking for the speed in centimeters per second. I know it in kilometers per hour. So you do the same thing for step number 3, is setting up the dimensional analysis. What's the first thing I write down? You look at the units in the answer to determine the first thing to write down. So in this case, I'm looking for centimeters per second. So I'm looking for an answer that has multiple units, and the distance is on the top and the seconds on the bottom. So therefore, I need to go and find that. Well, it's readily available in the speed. So that's the first thing I write down. Now, down here, I note this part right here. Okay, I didn't have to give you the speed in kilometers per hour. The question could have read, I traveled 39.6 kilometers in 1.50 hours. So if that was the case, it wouldn't be, which is if you do the division, exactly the same number here. But you don't do the division. Okay, what you would do is you'd stack them together. Okay, you'd write the 39.6 kilometers here, and you over 1.50 hours, and that's what your starting material would be. Again, it has to be 2 units. So now what do? Well, dimensional analysis only allows you to change 1 unit at a time. So therefore, you have to pick 1 unit to start. And for some reason, I picked kilometers. Well, if the kilometers on the top, it needs to be on the bottom. And I can go to meters, because that's what I memorized. And then that would cancel kilometers. I don't want meters, I want centimeters. So meters on the bottom, centimeters on the top. I know that conversion. So I've canceled that. Now I have centimeters, which the distance unit I'm looking for. Now I got to go change hours. Well, hours is on the bottom, so to get rid of it, you got to put it on the top. Therefore, the minutes go on the bottom. And I cancel those, and I get minutes, centimeters per minute. But I don't want minutes, I want seconds, so here's minutes per second. Therefore, I get my number, answer, in the correct number of significant figures. Since it's all dimensional analysis, multiplication, division, I go back and I look in the question. I have 2 significant figures, so they have, 3. Sorry, 3. So I have 3 in my answer. I have 4 the one before. I do the math. It's this number, which doesn't have to be in scientific notation, units, rounding to the correct number. Okay, so therefore in this problem, you actually had 2 units in the answer, so I have to start off with 2 units. The other thing is, if you wanted to, instead of stacking them like this, you could have actually created 2 parentheses. One with 39.6 kilometers over 1, and the next one, a parentheses in line, 1 over 1.50 hours. That would work too. Remembering that everything is done multiplying on the top if it's on the top, dividing it if it's on the bottom, and you're only doing 2 numbers at once. Okay? Last thing I want to say about this is the reason why I told you in the beginning of the year to do multiplication and division, go to the numbers in the original problem, is because if you look at a lot of these numbers, I told you need 3 significant figures. Well, that has 1, that has 1, that has 1, this has 1, or 2, depending on how you want to look at it. It's usually considered 1. So why wouldn't there be 1? Well, the answer is these are special numbers. These right here and these right here are special numbers. They're called exact numbers, and they don't play the significant figures game. The other thing is they are not usually in the question. So that's why I make you go back into the original question and look at the numbers in here, because almost never are exact numbers in the question. That's why I do it, and I don't make you look at the actual mathematical manipulation. So that's dimensional analysis, a way of determining significant, solving mathematical problems in chemistry, in my chemistry class at least. And the key is the start. What do you put in the bracket? And that's all depends on what are you looking for. Units, that is. Always about units. What are you looking for in the answer? The units in the answer. I can do this whole thing without actually writing any numbers until I get the correct unit and then fill the numbers in later. It would have worked perfect, the same exact way. So that's how you do it. And if you have questions, come and see me. Thank you.